Greetings and welcome to another Dev Bootstrap screencast. In this screencast we're going to check out the Etherscan Block Explorer application, which is a web application where you can check all the transactions and the blocks and the data of the blockchain in real time. It's a great way to get yourself immersed in what's going on the blockchain. It's an easy way to check things are happening as you expect. Of course, you can use Geth, you can use the command line, you can use Truffle. We'll be using both Etherscan and Truffle in this screencast. So let's head over to our browser and check this out. Firstly, I just want to make sure or let you know that we'd be using this repo here, Simple Store, which is under the Dev Bootstrap repository. So just head over to github.com/Dev Bootstrap, click on Simple Store, and then go ahead and clone that repo to your local computer. By the way, if you're interested in learning more about blockchain and being a full stack blockchain developer, then head over to devbootstrap.com and click on free videos, and you'll get a bunch of videos that you can check out. And I'll be publishing videos as often and as regularly as I can. So without further ado, let's have a look at the Etherscan application. If you've been working with Ethereum and blockchain for a while already, you would have most likely use this application quite extensively, and this video is hopefully going to show you something new. Maybe if you've been using this for a while, you probably know quite a lot about it, but there's always something that's kind of interesting and useful that I find I discover when I use this application more often. So on the home page you can see the latest blocks over on the left, and on the right you can see the latest transactions. If we dig into one here that was mined 3 minutes ago now, you can see the status, you can see the transaction hash, the block that it was mined in, when it was mined. This is the block timestamp that it was mined in, who sent the transaction, where it was interacting with, what tokens were transferred, if any, and the value, and so on and so forth. And we'll look at this in more detail in a bit. What I want to do now actually is start to interact with the Ropsten blockchain using my own account, and then inspect the transactions using this application. So over here I've got my MetaMask open, and I've got my sort of Dev Bootstrap demo account. I can click on the account to copy that to my clipboard and paste it in here, and then hit return. This view here is a view of an address, and as you can see, this is essentially a brand new address without any transactions having occurred yet. So what I can do is I can copy this again just to be sure, and go over to this testnet faucet and paste it in here and click send to. And if we are lucky, it will work. Sometimes this doesn't, sometimes it does. It looks like it's worked, and here's something already. We've got this transaction ID. So, well, let's copy that, and let's open up another window here and paste it in here. And you can see that this transaction is pending. It's pending because it hasn't been picked up by a miner yet, or it probably has been, but it hasn't been mined. But it's most likely in a transaction pool somewhere, and it's yet to be actually mined into a block. Now, on the Ropsten testnet, this doesn't usually take very long, so it won't. It should be completed soon, and all the once it is completed, the various applications will be propagated with that information and should update. So you see here it says done, you see here now it says success. Moreover, we can go to our wallet and we can see activity, and I think I have to just refresh. You can see our balance, by the way, is now 0.5 Ether. But it seems like I have to refresh to get this activity. Oh, maybe not. Yeah, okay. So perhaps the activity will not show for incoming. Well, never mind for that one. So we have the transaction showing up here. So let's quickly dissect this transaction, and then what I'm going to do after that is head over to Truffle, and we're going to deploy a smart contract. We're going to deploy that simple store smart contract using this account. So firstly, quick dissection. The transaction hash is the hash of the transaction that was mined into the blockchain. Status was success, so that means that it was successfully mined, and it was mined into this block here. Now this is a link we can click, so we can open that, and you can see there's 2 block confirmations, and we can see here the details of the block, and you can see that there are 20 transactions. So we know that one of those 20 transactions is actually our transaction. So let's click on that, and we can see a list of transactions in this block. So now it's like, okay, well, which one is ours, right? Well, one way of doing it is to go back to our transaction, click on here to get the transaction hash, come back to this list, just use the good old browser find, and there it is, and that would take you back to the transaction. But what you can see here is an interesting sort of view of the order of transactions as they went into this block. And the first transactions are at the bottom here. So you can click this little I, and you can see here that, in this additional info that appears. This is very useful if you're in this view to see a little bit of details about each transaction without having to click into the full page. So what you can see here is that this is in the position 0. And that means that that was basically the first transaction to be mined in this block, in the block that we are currently viewing. And as you click up, you'll go through the order of transactions. So if you want to see what order or what position our transaction was mined in, you just click on that, and we can see that it was mined in position 13. Unlucky for some, but that's one way of getting the position, and that's one way of seeing, where is your transaction in the scheme of things, I guess, in the block that it was mined in. So if you want to see the position as well, by the way, on this view, you can click to see more, and it shows you here under nonce and position. So nonce is the nonce of the account, and position is 13. Actually, this is not the nonce. So this is okay. So yes, this is the nonce of the sender. So what this means is that the sender was the faucet, and the recipient was our account here, which is this one, 3AD, this account here. So just to explain, this faucet basically is a smart contract. You can see here the address of the smart contract here, 3B873, which is the contract here, 3B873. So when I made this request, this made a transaction to this smart contract essentially, which then said, okay, yeah, transfer 0.5 ether from itself, so from the contract, to this account. And you can see actually here the name of the function, or the function that was called. It's called give to address and then who. So that gives you a little bit of insight. So you can see actually, interestingly, that 11,574 calls, if you like, to this contract have been or calls to this account here have been made. This is the nonce of this account here. There are other details here which obviously we can dive into, especially relating to things like gas and gas price and gas limit and gas used. These are all subjects which of course we can dive much deeper into, but the gas price is what was submitted by MetaMask for performing this transaction. as you can see on the testnet, it's pretty low, and it's generally always, I think that's the default, or around about the default value that you'll see on Ropsten generally. The gas limit is also submitted by MetaMask, and it's just sort of like a limit of how much gas we're willing to risk, if you like, before we want the transaction to revert. But you can see here that we were way under that. We used only 65% of the gas limit that was submitted. So that's that's a little bit about the transaction there and how that looks on the blockchain. Now you can again copy this, and we can take a look at that in Truffle. So if I head over to a Truffle, this is the simple store actually. So I'm going to go over to a browser. To the console here, and I'm going to go into this, and I'm going to type Truffle console network Ropsten, and this will connect to the Ropsten network. And if I type accounts like so, you'll see the account of the address of the account that we just were working with. And I can check the balance using Web3. So Web3 ETH get balance accounts 0, like so. And there is the balance. If you find this difficult to read, it's because it's in Way. Just divide it by 1e18 to get Ether, and there it is, 0.5, right? Which is what we just were transferred in. Now, I just want to quickly show you my Truffle config before we proceed, so you can see how am I connecting to the Ropsten network and why is it picking up this account. So if we head over to the Visual Studio Code or VS Code and look in the Truffle config file, if you scroll up, what I'm doing initially is I'm loading some environment variables using the .env library. And this brings in everything in this file here, the .env file, which contains two key entries, if you like. One is the Infura, what I call Infura PK, you can call it whatever you like. That is the private key of the account that we're using right now. So it's the private key of that account that has 0.5 Ether. And then this is the project ID. And then further down, I've got the config for Ropsten in particular, and I use the HD wallet provider, and I pass in the private key and the project ID like so. And then I set a few defaults. This comes with Truffle config, by the way. And I'm not going to go into Truffle. I just wanted to show you how I set this up and use it to connect to Ropsten. But what I do want to do now is deploy this smart contract here. Right, this simple store smart contract using the account that we have loaded in here. So to do that, you just run migrate. And migrate will compile the contract, and then it will migrate them. And it's going to migrate it to the Ropsten network because that's the network we're connected to. And it takes a little bit of time, especially more time than if you were connected to, say, a local ganache or whatever. But, well, the cool thing is, and this, by the way, this output here, happens. But we can take a look at where are we? We can take a look at the hash address here, and we can drop that into our Etherscan, and we should see, we've got the contract created already, actually, 25 seconds ago. Created from this account, 3AD account, the one that I've loaded up here in MetaMask, 3AD D2. And it created this contract. And you'll notice there's a slightly different sort of display when you look at transactions that create contracts. It just says to, and then square brackets, contract created. So this is a sort of special, if you like, transaction because it was a contract creation. The to was not another existing address. It was creating a new address with a contract at the end of it. So we can click on that now, and we can see that contract appear here, and I can just expand to see more, just to see what else was sent along with this contract, with this transaction. And you can see, as expected, the nonce is 0. This is because this is the very first transaction made by this account. It's not the first transaction to that account because we had something sent in, but this is the first transaction that the account initiated. So that's why we have a nonce of 0. And remember here, this is the position of this transaction in the block, in this block. And remember, if you click on this, you get the block details, and then you can click on the transactions, and it should be here because this is position 1. And sure enough, that is our contract creation right there. And you're only going to see this kind of thing, 4 transactions in one block, very low in testnet. In mainnet, you're going to always see a lot of transactions in each block. Anything else interesting here? Well, you know, the block height and everything this is the block details. We can go into this in another screencast perhaps. And then our contract creation, it sent, this is interesting, it sent 20 Gwei as the gas price. Why did it send 20 Gwei? That is the default in Truffle Config. I think that Truffle itself will be sending the gas. In fact, we can check if I look here. If we go back here, we can go and look at Web3 ETH get gas price. We can see what that returns. Okay, that returned. Oh, it returned the. That returned the default 4.32, which is the typical gas price of Ropsten. I think that actually the 20 Gwei comes from the Truffle contract creation. That's what it sends when it's creating contracts. So yeah, now what we can do is interact with this. So I just exited out of that because it was giving me a lot of this error. You'll get that kind of, I don't know, timeout or whatever is the problem with Truffle sometimes when it connects to the networks. But I wouldn't worry about that. Just ignore it, restart it. You know, basically once you've got a transaction hash in your console, that means it's been submitted. So if you see errors on the client like we saw there, or if you get an exception, you know, in Web3 or in Truffle after you've submitted a transaction to the blockchain, it's still submitted to the blockchain and it can still be mined. And that's very important, especially, of course, if you're dealing with real Ether on the mainnet. You want to be aware that exceptions in the client don't necessarily mean that the transaction has reverted. So let's interact with that contract. So if we type networks and spell it correctly, networks like that, actually we won't. And this is another issue sometimes with Truffle, is that you won't necessarily always see the deployed smart contract. So one thing we can do is we can either fetch it using the @address API, or we can update the build. So if we look in here in the JSON and scroll down to the networks, it's empty, unfortunately, and that's because of Truffle not really working so well sometimes. But sometimes you'll get the networks in here, and you can just update the address manually. Actually, it did seem to work with migrations. If we go down and look at migrations, you can see here, yeah, networks, and then there's a 3 and all that. So we could try this. I can copy that, put that in here, like so, correct the number of braces and stuff. And then really all I need to do is update the address. The transaction hash doesn't necessarily matter, but I'll do both for good measure. So this is the transaction. So I can just drop the transaction hash in here, and I can drop the contract address here and put that in here, and then I can save it. This, you know, as I say, this should have been done by Truffle, but it times out or has errors, as you can see here. So let's reconnect again, and we'll try the networks command, and hopefully this time we can see the actual contract details. Yeah. So now that it's picked that up, thanks to me, we can load it. So I can just say sort of simple store, just do ss await simple store, and I can just use deployed now. Oops. Deployed again, if I can spell that correctly, right? So this is as opposed to using something like simple store.at, right, and then having to type in the address every time. Here we can use deployed like this because I've added it to the config. So now SS is our instance. So we can actually polling error. Yeah, like I say, it does this a lot. It can be quite annoying. So that means I've got to actually load this again. All right, let's try this. Let's be quick this time. Simple store deployed. All right, and then I should have put await. All right, now I can do simple store get value, and we should see a value of that, which is okay. That reverted. That's interesting. Why would that revert? Let's just take a look at this contract. Get value. The constructor sets the value to a default, and the migration should have set it to hello world, right? So. That shouldn't have reverted. It does. Every time. Okay. What about set value? That's okay. Okay, that had a set value, had a revert as well this time. Okay, so welcome back. I took a quick break to check what was going on with the smart contract, and it seems like the deployment had some kind of error, but I couldn't see any error actually on the blockchain. So that's an interesting one that I've first time I've seen that actually. So it could be another issue with Truffle. Not really sure, but I just basically ran migrate again. So you can see here, I literally just ran migration again, and it started the migrations. It deployed the contract. You can see different transaction hash and so on, different contract address. Gives you all the information actually that you would see also in Etherscan. And now if I check the networks, I can see the updated address, and moreover, and more importantly, if I fetch the contract using this syntax and call .value, I get the hello world value that was set. And now in Truffle here, I can call set value, and hopefully this will work. So if it doesn't keep doing that, we'll just say dev bootstrap. Okay, and I'll do that, and that should send that as a transaction off to the blockchain. And Truffle is going to be using my account that is imported using the private key. And as we can see, here's the receipt. Again, we got all the details of the transaction, and we can see the block that the transaction went into. So let's go back up, get that receipt back again here. So let's have a look at the transaction on Etherscan. So we drop that transaction ID in, and let's have a look. Click to see more, and you can see here that yes, it called the set value function on our smart contract there, and so this is the method ID in hex. So it's basically the method signature converted to hex, which is what is used by the input when sending a transaction. And we can actually view the input as different values, and we can see here, like input, looking at it as UTF-8, you can actually see the string that I sent along with the function there, which is encoded in here somewhere. So that's really cool. And again, this is great for inspecting the transactions to see, was enough gas sent and so on and so forth. As you can see, we didn't use very much gas. Huge gas limit was sent, 5.5 million, but we only used 0.5 of that to mine this transaction here. So we can go over to the terminal again, and we can actually call get value, and this should return the new value that we set. So that's what I wanted to cover today, just a quick overview of interacting with the blockchain via Truffle and the testnet. It's a similar, if not almost identical experience with mainnet. As I said, to go to mainnet, you just remove Ropsten, the subdomain, from the URL, and then you're in the mainnet Block Explorer. And it's exactly the same. There's a few more features on here. Obviously, a lot more going on, a lot more traffic, perhaps a lot more useful. But generally, if you're going to be using Truffle and you're going to be using Etherscan, then what I showed you just then with Ropsten is how you would probably experience it with mainnet, including the issues that I had. And like I said, the contract having that issue where it was reverting is the first I've seen that. Actually, usually contract deployments go pretty smoothly, and when they're mined and confirmed, I can then begin to interact with them with no problem. So if you see something odd like that, perhaps you just need to deploy it again. Obviously, on mainnet, that's going to cost you more money. I deployed a contract recently, and it costs $75 at that current gas price and current price of Ether. So obviously, you want it to work first time. But yeah, that's generally what you need to do is interact with the blockchain and check the Blockchain Explorer using Etherscan. Now, of course, all of this data is available through the Ethereum API directly in a Geth node, or using Web3 or other APIs or SDKs, and you can try all of those out. And please leave any comments in the comment section below if you have any ideas or any things that you want to point out, or any things that you like about Etherscan or hate about Etherscan and Truffle. And yeah, just stay in touch, and I'll try and respond as soon as I can. And I'll be back soon with another screencast. Thank you, everyone, and have a great time programming and developing on the Ethereum blockchain. Thank you.